I'm going to post the answers to this worksheet, but I also wanted to talk through some of these problems and show you where they came from in your note packet. So for the first question, this was example 1 on page 3, determine if the following are functions, and then explain why or why not. Some of you just circled yes or no, and then that was it. So for the first one, it fails the vertical line test, so it is not a function. For the second one here, is dog breed a function of life expectancy? So F of L, that's going to be on the right-hand side, and the dog breed, D, is going to be on the left side. So if you think about this and drawing up a picture like we did, life expectancy is the input. So I've got life expectancy here mapping into dog breed, the output over here. That's what letter B is asking. And I can see the number 9 is getting mapped into 2 different dog breeds. So in this case, it is not a function. Whatever comes closest to the word function of, that next word is your input. So for this one, is life expectancy, that would be the L, a function of dog breed? Well, F of D then is on the right-hand side. D is inside the function, so that is your input variable. So this time, you're listing out all the dog breeds, and the input, or the output rather, is life expectancy. So I don't have the same dog breed listed here. You know, for a boxer, it maps into 9. And then even the chow chow maps into 9, but the chow chow doesn't also map into another life expectancy number. So because each input maps into exactly one output, it is a function. Each dog has only one life expectancy, not 2 or 3. For number 2, this was example 3 on page 4. The pressure is at a depth d feet given by this formula. The input is the independent variable. Remember, the INs go together. So the input is the letter D, and the output then is what comes out, what's on the other side of the equal sign all by itself. That's the output, and it's the letter P. Notice when we talk about input and output or independent and dependent variable, it's just a letter. It's not a whole expression. Question number 3 was example 4 on page 5. This is where you plug in your information, and this is where some of you just gave me a number and then the number was wrong, so I couldn't give you any partial credit. My best advice on this is either print out the page, write your work out completely on that page, and then take a picture using that CamScan thing app that I have posted on Moodle, or just write it on plain piece of paper, work out your work, and then take a picture of it and upload it to Moodle. But I need to see your work to give you partial credit. So again, when you take out a number, you put it in parentheses and then let your calculator go to town. If I don't see where the work came from, though, I can't give you any credit for it. Letter C, this is one that you're plugging in the x plus 2 into the f function. Don't forget that you need to write this down twice and then do the FOIL method. There was one again, like example 4, where we worked that out in the notes. For question number 4, this was example 5 on page 6. You solve, but it says express y in terms of x, which means you're solving for y in these problems, not x. Y is on the left, and then x and everything else is on the right-hand side. So if I can get it as y equals and just have one equation on one side, then it is a function. Because then for each x number that I plug in, I'm only going to get out one y value. However, in letter B, when I simplified that, got rid of the parentheses, get my x's on one, or my y on one side, everybody else on the other. I had to take the square root. And when you take the square root, you also have to include the plus or minus symbol in the problem. Because I have now two separate equations, y equals the positive and y equals the negative, when I plug in one value of x, I'm going to get two different values of y out. It's not a function. Question number 5 was on page 11, example number 10. This is where you were given 2 points and then use the slope formula to find average rate of change. So the 2 points that I'm using, remember your years are the x's, or your time unit, 2005, 2425, and then 2011, and 4026. So this is x1, y1, x2, y2, and average rate of change is the slope formula. Again, refer back to example 10. When you write this up, you do the division. You simplify the top, simplify the bottom, do the division so that it's a number per year. So in this case, rounding to 1 decimal place, 266.8 females, female prisoners per year is what the unit label is. Female prisoners was my Y's, the years was my X. So the explanation is this: each year from 2005 to 2011, there is an increase of 266.8 female prisoners on average. Somehow I need to see each year or per year in there. I need to see the unit label. I need to see what years you're talking about, and then if it's an increase or a decrease. So all that's what I'm looking for when you give me a statement about interpreting the average rate of change. For question number 6, this one, it's a little easier to see on your paper than it is my second copy, but this was -4. This, I believe, was the number 2. So estimate the interval where h of x is above the x-axis. That's what h of x greater than 0 means. So from negative infinity all the way over to -4, but not including -4. You can't have a bracket on this. A bracket means we can be on the x-axis or equal to 0, and we don't want to be equal. We want to be strictly above. So we can get really close to the -4, but don't put a bracket on it, because a bracket means you've landed on it. Where is h of x less than 0? So it's less than 0, or it's below the x-axis here, all the way over to here, and then it goes on the x-axis at 2, and then it goes below again here. So from -4 to 2, and then from 2 out to infinity, that's where it's all below the x-axis. So remember, you're reading off the x-axis when you tell me this above, below, and on thing. Where is it increasing? All right, where is it going uphill? From here, -2 to 2 is where it's going uphill. The range, you go from the lowest y value, because there's an arrow, it's going to keep on going down, to the highest y value, up to infinity. And then find f or h of 5. So when x is 5, I come over here and it matches up to, and again, it'll look better on your paper, it matches up to the number -8. And then find all x so that h of x equals 0. This is where you're on the x-axis. So we look back for the x-intercepts, and that would have been at -4 and at 2. That's where it's on the axis. Okay, so look back at your work. For the most part, I just took points off, and I'm still grading, so if you don't see yours graded yet, hang on, I'm doing it. But I wanted you to have an idea of how I want you to write up the answers, and if you're struggling with showing work or being able to write, you don't have to be able to write on your computer screen. just either download it as a worksheet and then write on the worksheet and then re-upload it, or write it on a piece of paper and then take a picture of the paper and upload it. But I need to see your work.